Welcome to Advancing Big Science. I'm Will Smallman, and today we've invited Chris Dagdigian to walk us through the intersection of cyber infrastructure, bioinformatics, and life sciences. Chris started his career as a scientist and a software developer before co-founding BioTeam, where he is principal consultant and director of technology. BioTeam is dedicated to providing technology solutions to life science researchers. Chris and his colleagues at BioTeam bridge the gap between the work of scientific researchers and their need to store and share data, making him the perfect subject for a conversation around building a technology ecosystem to fit the growing needs of scientific researchers. Chris, I'd like to start by hearing about what you do at BioTeam and your connection with the Internet 2 community.
Sure, happy to do that, and thanks for inviting me on. So I often introduce myself as a failed scientist. I'm someone with a background in computational biology and genetics, and I had intended to become a real scientist doing computational biology. However, I entered the field in the 90s where the Human Genome Project was in the process of exploding, and quite a few of the software tools that people like myself were interested in using simply didn't exist at the time. So I belong to a large sort of cohort of peers who came up in the 90s who basically, in order to get our science done, we had to become self-taught at IT and programming. So at first, I taught myself how to write code, and I wrote a bunch of software to analyze DNA. Professionally, for almost the last 20 years, I've really been doing mostly IT and infrastructure work for pharmaceutical and biotech companies. So I think I'm very similar to other people of my age. I think others concentrated more on science and concentrated more on software. I'm just one of the smaller group that sort of got into the field into the 90s and very quickly made a career transition to supporting the infrastructure rather than doing the frontline science. So BioTeam is an independent, honest, objective consulting service, and all we really do is happily sit at the intersection between infrastructure and IT and sort of help lots of different organizations bridge the gap. After the storage tsunami hit and the industry sort of got a handle on petascale storage, to be honest, in 2016, petabytes of storage is not a big deal anymore. It's actually harder to manage the data through its life cycle than it is to store it on disk these days. So very quickly, the issues went from Linux clusters to storage to a lot of cloud computing, and cloud computing kicked up a ton of new work in even just, proper system design, security, infrastructure automation, DevOps. And then that also kicked in a whole new world of network-related projects where once we had cloud footprints, we needed to connect to them securely and at very high speed. Internet 2, 2015 for us was the first big year in that we've always had academic and government customers who were on Internet 2, but it wasn't until the very beginning of 2015 or maybe a little bit before where we started actually seeing some of our industrial and commercial clients. Biogen, I think, might have even been one of the first official private companies to sign on as a full Internet 2 member, and I think they've kickstarted a sort of very long trend in that regard. We have more and more people hopping on Internet 2 as we speak. I think in 2016, more of our clients have joined Internet 2 than in all of 2015 and beyond.
Sure, that makes sense. So I'd like to kind of pivot back to something you were saying just a couple of minutes ago, because this is something you talked about at your conversation with Internet 2 at TechX in 2014. Data storage is largely a solved problem at this point, just within the last couple of years. Data computing is sort of a solved problem. But the big issue you saw looking ahead at that time into 2015 was really kind of managing scientific data through its life cycle. And I'm curious, as to whether you've seen any progress in that area over the past year and what you see as kind of the big challenge now in the early part of 2016.
Sure. So that challenge still exists, and there is a much newer, much scarier challenge that I'll address in a little bit. But I think the fact of the matter is that large-scale storage does feel like a solved problem. It used to be 4 or 5 years ago, if you were going to build a petabyte storage system, especially in a commercial setting, you were probably risking your job or at least risking your career in a relatively risky technology project that had to work, or else you would look quite bad. Petascale storage hasn't been scary in years. There's easily a dozen vendors that will drop something off at your loading dock within a couple of weeks of you buying something. So the actual mechanics of buying big storage are easy. The problem that we've seen is above a certain scale, and for me the scale is about 1 petabyte. If you have 1 petabyte of data and you do not have a full-time human being managing the curation and study of what you have stored, then you're probably wasting far more than the human cost of the salary in unnecessary, redundant, or duplicate files. We've definitely seen people spend hundreds of thousands of dollars on storage that they simply didn't need because they were unable or unwilling to fund or support or even find a place in the org chart for the human being responsible for sort of data wrangling, data curation, and data organization. But I think the combination of iRODS getting easier to use and the game-changing nature of metadata-aware storage that you can get with Object is probably the single biggest fundamental change that's happened in sort of, data lifecycle management. And if you combine that with the cost trends on the cloud, where long-term persistent storage for cold or nearline storage consistently seems to get cheaper month by month or quarter by quarter, there's other interesting things related to freighting backups or nearline storage into the cloud that customers are starting to see. So I think the data management and data lifecycle problem was the problem of 2015. It's still not solved. iROD still requires work, and it's going to be a decade before our industry is completely holed in on object storage. So the pieces are there. The problems are not fully solved. However, the much bigger and much scarier problem, and this is, again, where Internet 2 and other things are sort of coming into play, is I firmly believe that the single biggest infrastructure challenge BioTeam is going to be working on in 2016 and 2017 is actually terabyte scale data movement across networks. It is absolutely becoming clear now that we have so much data being produced and consumed in so many different locations that the new overwhelming bio-IT challenge for 2016 and 2017 is going to be, how do we efficiently move vast amounts of scientific data around on networks? And those networks could be on-prem, building to building, lab floor to data center, but more and more they're going off the organization, going to a public cloud or to a collaborator. And it turns out from an IT practices, from an architecture, from a security operations view, and even from a political view, we are just completely unprepared to handle these new requirements. In fact, I would say the vast majority of organizational business networks are simply unsuited for this requirement, and there is going to be a tremendous amount of network redesign and network reassessment that needs to be done. It's not even just the hassles of doing security at this speed. It's the hassles of separating the scientific data from the business data, and quite possibly buying into the whole science DMZ trend, where our larger customers are already physically or logically separating their business network from the scientific data movement network. So I think the problems with lifecycle management haven't gone away. Advances in iRODS and advances in object storage have sort of made it a little bit cheaper. But I think the almost intractable or very scary problem, it's going to be moving this data across wires, is going to be the single biggest pain point that IT people in the life sciences face over the next 18 months or so.
Great. And so you mentioned the science DMZ, and I think in earlier conversations with the Internet 2, you saw maybe some reluctance in some sectors to embrace the DMZ. And so have you seen any progress with that, and how widespread is that solution in your experience?
Sure. So the really nice thing about Science DMZ is that it didn't come from Cisco, it didn't come from a corporate entity, and it didn't come from BioTeam. So Science DMZ is essentially a set of best practices that have evolved out of the high energy physics community, which, to be honest, has problems that make life science look like a drop in the bucket. The high energy physics people have IT and infrastructure issues that are an order of magnitude beyond what life science is going to face. I think from an adoption standpoint, because Science DMZ is not owned by a vendor and because it has a history of being successful in the high energy physics community, it's actually not that hard to talk in general terms about Science DMZ and what it implies. Where you start to get resistance is the entrenched organizational and networking infrastructures at many companies are just not set up well to handle the requirements of Science DMZ. So from a political or slow uptick adoption, what we've had to do is, I have no trouble at all selling the concept of Science DMZ. The trouble that I have is putting it into practice at a pharmaceutical or biotech, where I may end up bending or sort of gracefully adapting the Science DMZ model to fit in with their preferred technology partners or their preferred vendors. And there are certain battles that I know I can't win up front. So rather than demand it up front, I recommend a trial or a proof of concept.
How do you see some of the network programmability innovations coming out of the Internet 2 community possibly being a game changer in the future for the networking necessities you mentioned, like SDN programmability and virtual slices?
So I'm not particularly familiar with virtual slices, and the only thing I'll really say about SDN is that I would say the Internet 2 AL2S service, particularly the self-service web portal that you can go to draw your layer 2 connectivity out, it's probably the most impressive and most useful real-world example of SDN that I've ever seen. Most of the SDN stuff that I see in commercial pharmaceutical or biotech, it's really cheesy vendor examples that were clearly faked up just to do a white paper or a heavily subsidized use case that doesn't quite match what you need to do in the real world. So I think one of the nice things that's coming out of Internet 2 is that it's actually showing cynical people like me that software-defined networking is more than just meaningless buzzwords. It can actually be used to do something meaningful. However, I don't see the adoption of SDN all that much in industry yet, simply because we have a tremendous pile of legacy networking kit that is unlikely to be adopted or updated or switched out with something that supports OpenFlow. Where you're starting to see it is a little bit in virtualization environments, a little bit in private cloud pilots and trials, but I would say all of the SDN action that we've seen is in public cloud environments or on Internet 2 via the AL2S stuff. I would say the single biggest contribution that Internet 2 has provided my commercial customers is just the nationwide 100 gigabit backbone that was purpose-built to support data-intensive science. When you go down the Science DMZ rabbit hole and you see the catastrophic loss on data throughput that even a fractional amount of packet loss on a TCP network will cause you, you really start to value and realize why you signed up with Internet 2 in the first place. Internet 2, purpose-built for data-intensive science, and doesn't drop packets at anywhere near the rate that we see when we're trying to use more traditional, network connectivity methods to connect to clouds or collaborators.
Great. Yeah, and you touched on it a little bit because that was, I wanted to lead into kind of talking about your work and projects utilizing the Internet 2 network. How have you engaged with the Internet 2 community to make progress over the past year in that area?
So, I think our biggest engagement has been BioTeam starting to put the Internet 2 TechX and events on our schedule, both as attendees and speakers. I think we ended up getting trapped in our little rarefied world of going to Amazon reInvent every year, going to Supercomputing every year, and going to BioIT World every year. It turns out that there is a tremendous amount of useful information for people who've gone down this road before life science did to be met at some of the Internet 2 events. So I think the major outreach that we've done is we've started to add Internet 2 events to our internal calendar, and more often we're encouraging our customers and clients to attend those meetings as well. Each one of our customers is in a different geographic region, and the Internet 2 people that they talk to are slightly different in each region. So I think there's no common story about how we engage with Internet 2 from a perspective of getting our clients hooked up, but from a knowledge sharing and sort of general community involvement. I think I even said it on stage at TechX in 2014. I think Internet 2 should expect an influx or maybe even a mini flood of life science people to their events over the next couple of years. I think some of it being driven by pragmatic desire to learn from the Internet 2 community, and hopefully a little bit of that flood is coming from people like BioTeam sort of evangelizing on both the quality of the agenda as well as the caliber of the attendees who show up to these events, and will happily network with you or chat with you over lunch about very, very useful stuff.
Right, and it can serve, do you think, maybe as sort of an incubator of kind of ideas and kind of forward-looking concepts and maybe pushing forward advancement in a way that wouldn't be possible in isolation?
Yeah, I absolutely agree. I think, when you go to an Internet 2 event, it's clear that the people who are there, they may not be in your industry, but for many, many years, they've been trying to tackle with really hairy questions around federated identity management, or really hairy questions about how to do security on high-speed networks. So, yeah, I think it's the caliber of people. It's the fact that they've worked on similar problems, although maybe outside of life science. And I really do see it as an incubator. I think in many ways, some of the Internet 2 attendees are using technologies that are a little bit advanced of, what I might be allowed to wedge into a pharmaceutical company. But I can go to an Internet 2 meeting and I can get practical advice on what to think about now, and also practical advice on, what products and techniques, I think the more conservative enterprise organizations might be using, 1 year, 2 years, 3 years down the road.
There are decisions that are being made in a lot of cases by kind of non-technical people at the C-suite level, chief information officers, chief financial officers, CEOs. So what would you say are the top infrastructure projects that group should prioritize for investment in the coming year or two?
So I think the main thing is prioritizing network refreshes that would facilitate Science DMZ-like separation of science data from business data. And if the C-level executives, if they look at their graphs and trends of what the enterprise network is doing, they simply don't see the high-speed scientific data flows. So typically, they're not budgeting for 40 gig and 100 gig links because simply it doesn't show up in their graphs. I think the other thing is that it is absolutely clear to me that incumbent enterprise security practices, particularly practices that require that you place a device in line with the data flow, something doing deep packet inspection or APT analysis, that does not scale. Any security practice that requires putting a device between the sender of the high-speed data and the recipient of the high-speed data, that doesn't scale, or it's extraordinarily expensive to build a system that does. And so I think longer term at the C-level thing, they need to be investigating and researching completely new methods for maintaining security controls in the enterprise that do not rely on inline deep packet inspection, which basically just drops your throughput down by an order of magnitude. They're going to have to go to next generation security technologies, many of which they have not previously deployed in the enterprise before. And so it's going to be a bit of a learning curve and maybe even political hassle to get those accepted for use in-house.
Well, that sounds like a convincing argument to me. Well, thank you very much, Chris, for talking to us.
All right. Thank you guys so much. And thanks again for the opportunity. It was great speaking with you.
Thank you, Chris. And thank you to our listeners. This has been Advancing Big Science with our guest, Chris Dagdigian. We hope you enjoyed it, and we look forward to seeing you at the BioIT conference in Boston.